Section 8.3, Rational Exponents. So first off, we're going to go back over the rules for exponents that we learned in section 1.4. These are all in your book, and so I'm going to go through them quickly. First off, when we multiply bases, we add our exponents. When we have a power to a power, you multiply those exponents. When you have a product raised to a power, the exponent goes to all of the factors that were in those parentheses. If you have a fraction to an exponent, the numerator and the denominator both receive that exponent. Anything other than 0 to the 0 power is 1. When you've got division with like bases, we subtract our exponents. If we have a negative exponent, it flips it and puts that factor into the denominator. And the same thing, if it's in the denominator with a negative exponent, it moves to the numerator. Notice that in both of these cases, the negative, all it does is flip the location of the number. It doesn't change the value of that base. So one thing I want to go over. If we have this, now I know you guys haven't seen exponents that are fractions, but just go with me right now. So what we would do, what's a power to a power? So we multiply exponents. We have 1/2 times 2 over 1. Our 2's cancel out, we're left with 1. So what this means is that 5 to the 1/2 squared is the same as 5 to the first power, which is 5. And now let's think about what squared is 5. Well, the only answer to that is the square root of 5. Because if you look at it, square root of 5, when we square that, that's the same thing as root 5 times root 5, root 25, which is 5. So what that tells us is that this 5 to the 1/2 is the same thing as the square root of 5, because both of them, when we square it, give us 5. So we can generalize this to give us this rule. So an exponent of a fraction, like this right here, is the same as in the denominator as whatever our index is. So for example, for this first one, 16 to the 1/2, all this means is the square root of 16. Notice we don't write the 2 right here, it's just implied. Square root of 16 is 4. And if you can jump straight from here to here and do this step in your head, that's completely fine. I'm going to show all of my steps for this lesson, but if you can make that jump, more power to you. So this next one, since it's to the 1/3 power, this means the cubed root. And notice our number stays the same that's inside those parentheses. It's now the same number that's in the root. And the cubed root of 27 is 3, cubed root of 8 is 2. And last but not least, notice this negative is on the outside. It's going to stay on that outside. 4th root, because it's 4 in a denominator, this negative will stay out front. 4th root of 16 is 2. X to the 4th with the 4th root is just x. So now we're going to go back the other way and just practice writing these using a rational exponent. And all that means is writing these with an exponent that has a fraction in it. So notice all 3 of these are underneath that root, so all of them need to go in parentheses. Our root was 6, so it's to the 1/6 power. This second one, notice it's only the x that's under the root. So only that x needs the exponent. And since it was a squared root, it's just the 1/2 power. One other thing to point out, if we have 4 to the 3/2, that's the same as 4 to the 1/2 cubed, just separating it out, because if we went the other way from here to here, it would be 1/2 times 3, which is 3/2. So I'm just going kind of the opposite way that we normally do with our exponents. And if we look in this middle one, remember this is the square root of 4. Square root of 4 is 2, and when we cube it, we get 8. Now doing the same numbers, I'm just going to switch this and do 4 cubed, and then the half to the 1/2 power. Notice it's still the same because 3 times 1/2 is still 3/2. 4 cubed is 64. And the square root of 64 is 8. Notice these are the same thing. So we're going to do another example. Five to the 2/3. We can break that up as 5 to the 1/3 squared, which is the same thing as the cubed root of 5 squared, which is the cubed root of 25. Going the other way with our exponents on the second step, we could do 5 squared to the 1/3, which is 25 to the 1/3 power, which is still a cubed root of 25. Notice these are also the same. And this leads us to our next rule about exponents. That if you have a fraction is as an exponent that the numerator and or denominator is not 1, all it means is that this top number is still your exponent just like it has been before. The bottom number is then your root. So it's just combining the stuff we did back in Chapter 1 with the stuff that we've been doing with the roots. So for this first one, all this means is that it's 16. I'm going to try to color code this because the 2's on bottom, square root that, and then this third just means cube it. So square root of 16 is 4, and we still have this exponent of 3, which is 64. And you could do it the other way and you could do 16 cubed and then square root it. That part does not matter. You're just gonna, if you do the exponents instead of the roots first, it is going to be bigger numbers to deal with. So I tend to go with the roots first, but you could do it this way. And if you actually simplified that, you'd also get to 64. I tend to do the roots first, so I'm going to put that up here. So let's look at our second example. We're just going to rewrite it so we've got the cubed root of negative 27x to the 6th. All of this is squared. So doing our root first, so we still have the squared on the outside. Cubed root of negative 27 is negative 3. X to the 6th, when we take the cubed root of that, we're just left with x squared. And now this is easy. We can just square both of them. Negative 3 squared is 9. X squared is x to the 4th. All right, now we're also adding in negative exponents. So we've got this negative here. Remember, all that means is that it moves to denominator. And it just moves the base. In this case, our base is that 25. And when we move, then that exponent becomes positive. So now we've got 1 over 25 to the 3/2. So once again, let's look at our roots first. So this is the square root of 25 cubed. Square root of 25 is 5. We still need to cube it. So you get 1 over 125. And now for this next one, once again, we've got this negative exponent, so it just moves this entire base to the denominator. And then that exponent becomes positive. There we go. So same thing as before, take care of the negative first, and it just moves everything to the denominator. Change it to roots. But notice now we have the 4th root of a negative number. So because of these two right here, this is not real. We've already talked about this situation. You can't have a negative root if your index is positive. Sorry, is an even number. Alright, so this next one. Remember from slide 1, if you've got an exponent on the outside, it can multiply to both exponents in here. Let me erase that last mark so you can see the number. So when we have 1/3 times 6 over 1, this becomes a 1 and a 2. So that means we had x squared. And now doing our y, we'd have 3/2 times 6 over 1. And y to the 9th. So the exponent rules haven't changed. It's just that now we're going to be doing fractions with our exponents. So you'll have to remember how to add and subtract and multiply your fractions. Alright, same thing here. Looking back at our fraction rules. Since these are the same bases, we want to add these exponents. So what we have is x to the 7/3 over x to the 1/3. And now remember, when we divide our bases, we want to subtract our exponents. So 7/3 minus 1/3 is 6/3, which reduces down to 2. So this whole thing reduces down to 2. Alright, last example. We want to distribute, so don't forget about that from chapter 5. And our exponent rules are going to be the same as what we've been dealing with, but I'm going to try to do this slowly and in multiple steps. So the first one, remember, we want to distribute this to both of these. I'm going to erase some of the work from the other one. And for right now, I'm just going to write it out and worry about my exponents later. And then remember, this one then gets distributed to both as well. And now let's go ahead and combine whatever exponents we can. So notice here we can add our fractions, because when it's multiplying like bases we add our exponents. So we have 2/3 plus 4/5, common denominator 15, multiplying the second one times 3, the first one times 5. So we actually get p to the 22nd over 15 minus, now notice these two, they both have p's and r's, but those exponents aren't the same, so we cannot combine them. Now remember, there's a 1 here that we're just not writing, and so we have 1/3 plus 1, 1/3 plus 3 over 3 equals 4/3, so minus r to the 4/3. And you can leave it like that. So the key things here, just make sure you keep in mind your exponent rules and your fraction arithmetic.